Good morning. Thank you for being here. I'm sure one advantage of going on first is that hopefully the audience is awake. The advantage for you is it can only get better after this. I'm going to talk about Sky's NG Core Network, which is something we've really built in the last 6 months. I looked through our range of very glossy templates we have, and this seemed an appropriate one, as it sometimes feels like this with the surge of data coming behind you and trying to keep ahead of it. So we've seen a really quite extraordinary, Sky has been operating for about 7 or 8 years, first as EasyNet and then as Sky, and we've really seen a quite extraordinary growth in traffic. Back in 2007, we were sitting at about 40 or 50 gigabits. Just at the start of 2015, we hit over 3,000 gigabits, which is really a quite remarkable growth. And the blue line is where we got to so far, and the pink dotted line is roughly what we think is our forecast for this year. So going above 4,000, maybe getting towards 5,000 gigabits. What's even more remarkable, in my view, is when you plot it on a log graph. So you've got the log scale of bandwidth on the vertical axis. It really is pretty well a straight line. So over 7 years, we've seen sustained exponential growth of a factor of about 1.6, 1.7, maybe 1.8 per annum, which is good if you're, because that partly is growth of customers and also, but very largely driven by growth of new services on the network. It's been quite challenging dealing with that rate of growth. We started the network using Cisco CRS-1, which did us for quite a few years. I joined Sky in about 2009, so when I joined there was a built network with a high-capacity router, it seemed at the time, with lots of spare capacity. And that saw us through till the end of about 2011, 2012, at which point we switched to the Cisco CRS-3, and I'll say a little bit more about these routers. Probably most people are familiar with them, but in case not, I'll just give a roundup. And that took us through really to about the middle of 2014, at which point things were getting very tight, and we knew in 2013 we'd have to do something about that. So before I come back to the routers, just to give you a bit of background on what the network looks like. It's quite a recent build, unlike some operators who've sort of got a long legacy of various networks and networks joined together. This network was built sort of from new to serve broadband, and it's a very concentrated network. We've got 2 lower nodes there which are in London, and the other 2 nodes are in Birmingham and Leeds. And within each supercore node, as we call it, we've got 2 P routers. One of the original reasons for going for 2 was we had this idea that we could maybe build one ring using one vendor's equipment and another ring using another vendor, and then if we had a systematic failure, major BGP software problem or something, and one ring went down across the ring, then at least the other one would keep going. That eventuality has never happened, and the operational and commercial realities were that we went for a single vendor, and as I say, we chose the Cisco CRS router. Next thing is so we've got 4 supercore locations. We've then placed about 65 POPs through the country, which are joined to the supercore routers at 2 different locations, 2 different rings in either case. The choice of number of POPs, basically the smallest number we could get by with, consistent with being able to connect to the exchanges. And there are the exchanges. They come into the POPs over leased lines, mainly from BT, but also from other operators. And the POPs are all, with just 1 or 2 exceptions, are on our own fiber network. And we go out to about 2,500, 3,000 exchanges and are able to cover about in the high 90s of our customer base with leased line unbundled ADSL 2+ service. We've also got started to use the BT fibre to the cabinet offering as a GEA presentation, which is brought into a smaller number of exchanges, but I won't be talking about that. So that's how we get traffic out to the subscribers. Traffic onto the network. Well, we've got 2 peering and transit points. which are for diversity, and they are generally meshed into all the supercore locations. I haven't shown all the links on this because it would get rather messy if you did, but the basic idea is traffic comes into the peering and transit and goes out to the supercore locations. That actually only constitutes about 45% of our traffic. More than 50% is served by CDN, and we've got a very large investment in on-network CDN estate, really located in 3 different classes of locations. I haven't got a pointer here, but the one there is on the mid-right is in custom specific CDN locations, very large server farms that serve into the main network. The one shown in the supercore location, which exists as all 4 supercore locations, is co-located with the supercore, which saves transmission, but obviously is not. Those are quite busy locations, so we don't want to put too much CDN there. And the last one we've been doing recently is to put the CDN into the POPs, shown on the right, on the left there. So, last thing is how just a bit of background to resilience. Nothing too unusual here. See, we've got two rings. We dual feed each POP from 2 different locations, and we've got 2 or 3 entry points into the supercore site, and dual P and T. The CDN is on a 1-to-n basis, so we've generally got 4 or 8 CDN locations. And the idea is that we can serve our peak traffic, which occurs, sort of in the evening, from without any congestion in the event of a major failure. And a major failure could be a very major failure, like loss of one entire supercore site or a major fiber route. And the effect of that, when you turn that resilience and dimensioning logic into sort of planning the network, you end up with quite a convenience equivalence that the biggest P router capacity we need is roughly equivalent to the total traffic served. It doesn't have to be that way, it just happens to work out that way. And that may seem a bit surprising because you've got eight P routers in there, but when you look at the worst case failure and the fact that we don't completely use each slot, and you've got a range of router sizes ranging from medium to very large usage, you end up with that equivalence. So that's basically the background to the network. So just coming back to the actual evolution of the build. The initial build was as I said, in Cisco CRS1. This is a 16-slot device, 40 gig per slot, which gave us 640 gigs per chassis, which when we were serving 50 or 100 gigs of traffic was a pretty big box. And it also had the growth potential of being multi-chassis capable. When it got to 2011, we looked at the options to go multi-chassis. Well, that wasn't very attractive. It was a configuration that would have needed a central chassis, and then an additional second or third, fourth chassis would have used a lot of real estate in the relatively full supercore nodes. So the option we did was to go to the just recently introduced Cisco CRS3, and we were one of the first customers to use the CRS3. The fact that we've got a very concentrated network tends to put us a bit on the leading edge of the node capacity and forces us to sort of use new stuff pretty early. Again, 16 slots, but now the capacity was uprated to 140 gigs per slot, which gave us 2240 gigs per chassis. And again, pretty large node compared to the traffic at that point, which was in several hundred gigabits, and that saw us for another few years. 2013, we could see what was happening, and so we started we put out an RFI and RFQ, and with the plan to deploy the new router early in 2014, when our largest CRS node will be nearing capacity. There wasn't a great deal of scope for delaying it. We really had to move. So just saying a little bit about the properties of the boxes. This isn't a commercial for Cisco, but it's maybe just give this background. The 2 boxes we chose were the ASR 9922, which we used for the peering and transit box. Choice of that was because it was already available. It had enough capacity. up to 7.2 terabits per node, which was pretty big for our peering and transit requirements, and had an evolution route in 2015 up to a larger configuration. So that was needed first for the peering and transit, which were getting very close to capacity. And for the supercore, we went for the as yet not available at that time NCS 6000, which looks like any other router. It's a very big box with a lot of fans at the top, which make a great deal of noise. And down the bottom, you've got the line cards. Unlike both the CRS and the ASR, it only has 8 slots for line cards, which did lead to a few issues which we had to address. It was basically something we knew we could deploy in the second half of 2014. And the capacity is 1 terabit per slot, which is configured as 10 100 gig ports. We were going to a 100 gig network, but quite a handy feature, the ports could be also configured for some interfaces as 10 by 10 gigs, which gave us a great deal of flexibility because we were introducing this into an existing, basically 10 gig based network, and we had a lot of 10 gig interfaces to handle. The other option was to go to a 60 by 10 gig port, but that didn't really have an evolution route. And it had a simple multi-chassis route, and we are the first and I believe the only UK user at present. Just a little word on optics. People are probably familiar if you use 100 gigs with a CFP and its future evolution to CFP2. Cisco have chosen to use this optic called the CPAC, which is, there's a photo here I just took, which is just under half the size of a CFP, and also, as I say, has this 10 by 10 option. Okay, I'm going to have to get a move on. Right. With the CRS, our diversity approach to diversity was fairly simple. We just basically allocated a slot to each different kind of connection. That worked well when you got 16 slots to play with. With the NCS, we had 8 slots, each of which had a very large capacity, and we had to rethink the way we allocated these slots to different connection classes and to preserve diversity of connection when in the event of a slot failure. And this allowed us to greatly reduce the number of different slots we used. So, getting on to the actual migration into the new network. We started with the peering and transit nodes. Difficulty we faced was we were nearing capacity on all the main P routers. We didn't have the luxury of overbuilding a overlay peering and transit. So what we did was we introduced a new peering and transit node with a connection to the existing node. Then we moved over first of our peering interconnects, ran that through the new node, and then to balance that, once we were happy with that, we moved over some of our internal connections. And this process repeated successively in successive steps. Sounds fairly straightforward, but you were working with a network that had relatively little headroom in the event of failure. So we had to do a lot of modeling to make sure we got this sequence of moves correct, such that we wouldn't place ourselves in an unbalanced traffic situation in the event of a failure. But that went pretty smoothly, really quite a rapid transition, very, very happy with that. Next stage was to go to the core migration. That's what our network looks like. First step was to introduce the NCS as a complete overlay. So we built a new core network with the NCS, got that running, quite happy with it. We connected it up to the CRS with those little black lines between the green and the brown nodes. Again, capacity constraint on that because we didn't have many ports free on the CRS. Then basically swung some sources over, peering and transit and CDN. I haven't shown the CDN. And then started swinging the POPs over. And that process again was repeated. Again, fairly simple, but had to be very careful. We've got a very highly connected network with lots of alternate paths and had to be careful that faults didn't cause overload on any paths. So a lot of modeling. One trouble we had was a shortage of 10 gig ports on the CRS because one of the interface cards we wanted isn't available till 2015. So that limited how far we could take it. And where we've ended up today is with the NCS network now, really from the end of December, carrying all the traffic for the net, distributing all the traffic for the whole UK network, with the CRSs subtended off it with those curvy dotted lines, basically with about half the POP traffic coming through the CRSs, but they're now functioning simply as aggregation nodes rather than true core nodes. And that's where we will operate, greatly reduced load on the CRSs until we can complete the 10 gig migration to the NCSs. Just a few words to say about the optical network. Got quite a substantial optical network, about 7,000 kilometres. Some our own fibre, some fibre swaps. Much of the canal runs along, much of the network in the south of the UK runs along canal routes. It was the old British Waterways Marconi network, which is still going and works very well. The core links between the main nodes, two London nodes and Birmingham and Leeds, stop off at various points for the POPs. And we've got those regional loops going down into the southwest, East Anglia, and the north of Scotland, coming off the main network. It's all pretty well pure optical network, very little regeneration now. And yeah, okay, I will move on quickly. In 2011, we basically were nearing exhaust of the 10 gig wavelengths. And so we went for a 100 gig transmission with 10 by 10 presentation. That was a very smooth transmission. We just had to do a minor upgrade on the OADMs because of the power monitor. A lot of change in 2014. We've gone to direct 100 gig connections between the NCS core router. We're all 100 gig in the core. We actually built a second fibre network, partly for capacity, but mainly because the existing network used DCM modules, dispersion compensation, and that impacts the optical performance. By going to pure 100 gig, we've been able to extend our optical reach and eliminate regeneration completely. Just a few words on traffic, on planning. That starts with a traffic forecast, and that's what it looks like over 3 years. The blue line is our forecast, which is done 6 to 12 months in advance, and the red and green lines are the 10% bounds on that. And as you can see, the traffic stays within it pretty well completely. And that's been a fairly accurate guide to traffic. So we start with a planning forecast, with a traffic forecast. We get the network structure from the network database, and we map it onto the optical paths, which allows us to see where we have shared failures. We use the Carradine Mate planning tool, which has been, it's simple, it's a fast tool. It allows very good modelling of multiple failure scenarios. It isn't good for modelling changing networks, and we had to do a lot of work to add an external framework for changing networks. And then we take the output of the Carradine and do some post-processing, which just runs out our capacity requirements and also does the nodal configurations for the routers to allow us to evaluate different network options and do budgetary pricing. There's not much to say on operational issues. It basically went very smoothly. No problems at all with the ASR 9K deployment. The NCS was also very smooth. We had 1 or 2 minor software issues. They've gone to a new virtualized operating system, which was new to us, and 1 or 2 small issues there. But it's basically gone very well. We were able to perform in-software upgrades, in-service software upgrades very smoothly. So that's the operational experience has been good. And lastly, I give acknowledgements. It was, looking back, it was a very major program, and it sounds a bit corny, but it was made possible by a great team of within Sky in these various areas who've worked together very well, particularly the operations, who had many late nights or overnight sessions to do a seamless upgrade. And yeah, so far we've kept ahead of the data wave like this able surfer. Okay, so I think I've got 2 minutes, maybe time for 1 or 2 questions. Sorry? Oh, 5 minutes. Oh, right. Oh, you gave me a false alarm there. Yeah, okay. Thank you. Yeah. A microphone here for this guy.
Hi, Neil McCrae from BT. Very great presentation, Tim. Thanks for that. I have two questions. On your optical network, are you using ROADMs?
Yes.
Yeah.
Yes.
Okay.
Yes, very much so.
And the other question is, where are your broadband access servers in relation to the core network?
You mean the BNG?
Yeah.
They're located at the POPs. We had an earlier set of equipment which did the PPP determination within the ISAM, but we've migrated all that back to the POPs. Yeah. Yeah.
Thanks.
Yeah.
Brian Nisbet from HEANet. Have you had any interesting outcomes of being the only people in the UK using the particular router you're using from the point of view of support or maintenance?
We've had very good support. Clearly, we are the first user, so Cisco is very keen that this should be successful. So we've had very good support from them. I don't think we've had any. I mean, we were apprehensive going first, but we've done this before, and it's basically gone pretty smoothly. I think more smoothly than I had expected, to be honest. Yeah.
Jim Reid. I was just wondering about the deployment of all this new kit that you've got. Have you any plans to set up your POPs or have a presence at the other regional internet exchanges in the UK that Lynx is rolling out?
Yes, I'm network architect, and from an architectural point of view, I would like to have more northerly connections because that would give a much more balanced flow within the network. Trouble is, most of our traffic comes in from people who are only in the south. So, yeah, I think there will be a move to use that northerly real estate, but it'll be slow. Yeah, yeah, yeah.
Okay, thank you very much, Tim.
Okay.
Oh, wait a minute. No, I've got a question from Tim here.
Tim Chown, I'd just be curious as to what the breakdown of that 5,000 gig of traffic is, just roughly.
The breakdown, well, I would say about 65... Sorry?
That's not on the buzzword bingo card.
I would say about 65-70% is online video. That's what has driven the surge in the last couple of years, and I don't see that abating in 2015. Maybe beyond then we start to see a curving off, but we're still thinking hard about that. Yeah. Yeah.
Okay, thank you very much, Tim.